so today we're going to continue talking about velocity, but specifically we're going to talk about instantaneous velocity, and we're going to start talking about acceleration. So what is instantaneous velocity? Well, instantaneous velocity is the average velocity in the limit as the time interval becomes infinitesimally small. So what does that mean? Well, in math language, this is what that looks like. The velocity is equal to, remember, velocity is our change in position over our change in time. But in this case, instantaneous velocity is when we pretend the time limit is as close to zero as we can get it without it actually being zero. So imagine that there's a football player running down a field, and someone snaps a picture of him when he's halfway down the field. He has an average velocity for his entire trip, right? From when he started to when he ended on the other side of the field, he has an average velocity. But he also has an instantaneous velocity in the exact moment that that person took a picture. Now, average velocity and instantaneous velocity could be the same number, but they don't have to be. So let's look at these graphs to figure out when they're the same and when they're not. In the top graph, we have a car that's traveling at 40 kilometers per hour the entire time. The average velocity for this car, from the beginning to the end, is 40 kilometers per hour. And if we look at any given moment along the travel, the instantaneous velocity is also 40 kilometers per hour. However, down on the bottom graph, you can see that the velocity of this car is changing over time. It starts with a velocity of 0, speeds up, and then it stays constant for a little while at about 50 kilometers per hour, and then it slows down to about 20, and then it stays constant at 20 for quite a while, and then it goes back down to 0 kilometers per hour, so it stops again. The average for this entire time is about 30, and you can see that by the dashed line. So if we average all of these together, it's about 30 kilometers per hour for the entire trip. However, if we want to know the instantaneous velocity at certain moments, they might be equal to 30 and they might not. So right here, the instantaneous velocity is about equal to the average velocity. However, down here, the instantaneous velocity is much lower than the average velocity. So instantaneous is when you take a particular moment in time. An average is when you average the velocity over a time period. So now let's talk about acceleration, because clearly this is not a constant velocity. The velocity is changing, and we need to talk about what that means. So what is acceleration? Well, acceleration is defined as a change in velocity. Any change in velocity. And there are three things that will cause us to say that an object has acceleration. The first one is pretty intuitive. When we talk about accelerating in a car, this is usually what we think of. Anytime an object speeds up, it's accelerating, right? Its velocity is going from a low number to a high number in a given direction. Its velocity is changing, it's increasing. The opposite of this, which we don't usually think of, but it's right there, is when an object slows down. So even though your velocity is going from a high number to a low number when you step on your brake pedal in your car, it's still an acceleration. Acceleration does not just mean speeding up, it also means slowing down. It's any kind of change in velocity. And the third one is interesting. Remember, we talked about velocity being a vector quantity, which means it has magnitude and direction. It turns out that a change in velocity doesn't just mean a change in magnitude, it could also mean a change in direction. So anytime an object changes direction, it is accelerating. So now let's think about a car. What kind of controls in a car could make you accelerate? Well, what makes you speed up? This one's pretty simple. The gas pedal is what makes you speed up, right? It feeds gas to your engine, makes your wheels turn faster, makes you go faster. What about slowing down? Well, slowing down happens because of the brake pedal. Anytime you step on the brake pedal, you are lessening your speed. You are changing your velocity. So you are accelerating. And finally, a change in direction comes from your steering wheel. So when you go around a corner, or if you're going around one of those loops, one of the ramps onto the interstate, and you keep a constant speed, it doesn't matter because you are still accelerating. You are changing your direction, which means a change in velocity, which means an acceleration. So now, what is acceleration? Mathematically, we're going to talk about it as a change of velocity over the time elapsed. And just like for velocity, this is average acceleration. This is the acceleration over a period of time and not necessarily at a specific moment. So if we look at the little red car, it's at rest at time equals 0. And it has an acceleration in the positive direction of 15 kilometers per hour per second. Now these are weird units, but you just have to think them through. 15 kilometers per hour per second. That means in 1 second, the acceleration will have changed by positive 15 kilometers per hour. So if it starts with a velocity of 0, in 1 second, the acceleration will have increased by 15 kilometers per hour. So its new velocity after 1 second is 15. After 2 seconds, it has changed by 15 in the first second and 15 in the second second. So it's 15 plus 15 is 30. After 2 seconds, this car is now moving at 30 kilometers per hour. And you can do that for any time. So over here, it's time of 5 seconds. If we were to do this out, it would be 15 kilometers per hour in the 1 second, 15 in the second second, 15 in the third, 15 in the fourth, and 15 in the fifth. And this equals 75 kilometers per hour. So for each second, the car's velocity increases by 15 kilometers per hour. An acceleration is a vector, just like velocity. So we have to worry about the direction and not just the magnitude. However, for the next couple weeks, we're really only going to be talking about motion in one direction, which means in a straight line. We don't need to worry about saying the car is going to the left or the right or south or north or up into space. All we want to worry about is calling one end of the line positive and one end of the line negative, and sticking with it. So when you write down an acceleration, you not only need a number for your acceleration, you also need a sign that indicates the direction the acceleration is acting in. So on the previous page, this car has a positive acceleration. We said the car was moving to the right, which is our positive direction, and it's speeding up in that direction, so it has a positive acceleration. However, this car has a negative acceleration. It is moving in our positive direction, but it's slowing down, right? The guy is stepping on the brake pedal. So the velocity is changing from a bigger number to a small number in the positive direction, so it has a negative acceleration. The acceleration vector actually points to the negative direction, and that's how we know it's a negative acceleration. If we were to take this little arrow and subtract that one, we would end up with this little guy still pointing in the right direction, in the positive direction, but it's a lot smaller. So we want to be careful with terms here, talking about acceleration, because there is a definite difference between negative acceleration and deceleration. They are not the same thing. Negative acceleration is an acceleration in the negative direction. Any acceleration in this direction is a negative acceleration, right? We called this side negative and this side positive. However, deceleration occurs when the acceleration is opposite in direction to the velocity. So in the picture, we have a car that is moving in the negative direction. However, the acceleration is in the positive direction. So this is a positive acceleration, but given that the car was already traveling in the negative direction, it is also a deceleration. So negative acceleration and deceleration are not the same thing. So that leaves us with some more questions to look at. One, what does it mean to have a negative acceleration? Having a negative acceleration does not mean the object is slowing down. Having a negative acceleration literally means the acceleration is in the negative direction. So a car could be moving in the positive direction and slowing down, or it could be moving in the negative direction and speeding up. Both of those are examples of a negative acceleration. 2. Can velocity be positive and acceleration be negative? Sure it can. Just think about any time you've been in a car and you come to a stoplight. If we define the direction that your car is moving in as positive, in order to slow down and come to a stop, you need to have a negative acceleration. In this case, before you have come to a full stop, you're still moving forward. You still have a little bit of a positive velocity, but you also have a negative acceleration. And that's what's causing you to stop. 3. Can an object have zero velocity, but a positive or negative acceleration? Interesting question. Well, we defined acceleration as a change in velocity over a change in time. Many people will look at this and say, oh, well, if velocity is zero, that means that acceleration has to be zero. But remember, it's not velocity over time, it's a change in velocity over time. So when we write this out, we have a final velocity and an initial velocity. We have two different velocities here that we need to take into account before we can figure out acceleration. So if one of these is zero, let's say for example our initial velocity is zero, we still have a final velocity to deal with. So if the initial velocity is zero, we still have a velocity to deal with on top. It doesn't go to zero. To think about it conceptually, the only time you're going to have zero acceleration is when your velocity stays the same over time. So if you start with a velocity of zero, the only way you're going to have an acceleration of zero is if your final velocity is also zero. So you're going to have an acceleration anytime your velocity changes from zero over time. It's possible that in between the time from the initial velocity to the final velocity, you might hit zero velocity. But it doesn't stay there. It is changing. And anytime that velocity changes, you have an acceleration. And 4, what are 3 things that can actually be considered acceleration? Speeding up in any direction, but not changing direction. Slowing down in any direction, but not changing direction, or changing direction. You can mix these things together. So you could be changing direction and speeding up. Let's say you're in a high-speed chase and you go around a corner and you punch the gas. That is accelerating, but it's accelerating in more than one way, which is a little too complicated for what we're going to look at. So here's your homework. You should read the acceleration page and answer the following questions. What you need to do is write and draw pictures of a scenario for each. So I gave you a whole bunch of examples through this lecture of a football player running, vehicles, turning, all of those kinds of things. That's what I want you to do for these. So situation A, the object has a positive velocity with a positive acceleration. B, negative velocity with a positive acceleration. C, negative velocity with deceleration. And D, no velocity and positive acceleration. It would probably be helpful when you draw your pictures to include both velocity and acceleration arrows. Make sure they're pointing in the proper direction, and you might want to show size or magnitude by the length of your arrow. So if your object is going really, really, really fast, but it has a tiny acceleration, make a really, really long velocity arrow and a really small acceleration arrow. Have these ready to be turned in the next time we meet.